The stuff last week. Geometric sequence, remember the only thing that's different between geometric and arithmetic is geometric there is a constant rate. So each number is being multiplied by something, whether it's multiplied by a whole number or a fraction, different signs and whatnot. So the nth term of a geometric sequence is our rule. First term, your rate to the n minus 1. And what you had to do here was decide what the rate was. And hopefully you recognize the easiest thing to do is take the second term divided by the first, third term divided by the second, and so on. That's how you figure it out. Because all of these things should have a common ratio, a common rate. You get 1/3. Are we okay with that? So the rule for this would have been a sub n 81 times the quantity 1/3 to the n minus 1. And that's really all it was. Very, very straightforward. Remember to put parentheses around your rate when you raise it to your exponent. That's about as tricky as it gets. Okay. This portion of it, I'm assuming, was relatively straightforward. Am I correct in assuming so? Okay. Now, the other part with geometric sequence, a sub n was first term r to the n minus 1. The first tricky-ish part of this is when I had you guys find the rule when you had two terms. Because I'm going out on a limb that if you were given a specific term in the rate, that's easy. You just solve for the first one. You're okay with that. Now, in this case, when you have two terms, you're basically doing the same setup as you did when you had two terms with the arithmetic. You're setting up a system of equations. Okay? What you want to do is write it out. You start with your rules. So we have a sub n is our first term, r to the n minus 1. A sub n is our first term, r to the n minus 1.
Is this still part of 11.3?
This is still 11.3. Yeah, I'm kind of revisiting a couple of the last bits on it, and then I'll talk about the infinite stuff, which is, like I said, going to be really quick. So you fill in what you know. You know that your second term is 45. So that means the a sub 2 is going to be your first term times the rate to the 2 minus 1. You okay with that? What's your second term? 45. And it's just r to the 1. We get that. I do the exact same thing with the second equation. I write out what I know. I know that the fifth term is negative 1215. I substitute in my values. The fifth term is the first term, so the rate to the 5 minus 1. Well, the fifth term is negative 1215. Is my first term to the first term to the r to the fourth power. And now you wind up with a system of equations. You've got two terms. Excuse me. You have two terms with two variables. Which one, if I'm looking at left or right, which one would be easier to isolate one variable?
Left.
Correct. Which one should we get by itself?
45 divided by.
Correct. You want to get the first term isolated. What happens here is if you take 45 divided by r to the first power, that means that's your first term. Therefore, I take this and I substitute in. Okay? So negative 1215 is 45 over r to the first times r to the fourth. And now you have to worry about playing the game of war. What's r to the fourth divided by r to the first? R cubed. Good. Move this up a bit here. So I have negative 1215 is 45 r cubed. Now what? Divide by 45 then? Cube root it. Very good. So if you divide by 45 and you take the cube root, what do you get?
Don't you just do like,
3. Darn ACT.
Would you leave it at home?
Yeah.
So you divide by 45 and you get r cubed. What was that divided out?
27.
negative 27?
Negative 27. So that means my r value is negative 3. Okay.
Is there a cube root part?
There is. If you hit math, and then you scroll down, you'll see a 3 root. That's your cube root. I think it's option 4.
Yeah. So math 4.
Is it math 4? I'm not sure.
Yes.
Oh, yes. So now I know that my r value is 3, which means I take that back.
It's negative.
Excuse me, negative 3. Thank you. I take that back to here to figure out my
A.
first term.
Good. I think we did that one.
We did. It was on, I had it in the notes from before. It's a really easy example. I just wanted to just kind of re-show you guys in case you forgot. So now you have your first term in your rate. So your a sub n is negative 15 times negative 3 to the n minus 1. And there's your rule. Okay. Yes, ma'am.
So what if you cube whatever the number was, and it didn't count even? Like,
Well, you should get some sort of a fractional amount that does make sense. If you get something that's completely off the wall, you might have screwed up somewhere.
Can it be decimal?
Rates can be decimal, but usually fractions are easier. I mean, did you get one that was really weird?
well, it was on like stuff on my, I was just,
Do you remember which one it was?
yeah,
51.
but I might not find out stuff.
So let's see, at 51. So if I look at 51, a sub n, first term r n minus 1, a sub n, first term r the n minus 1. Well, it's the third term is the first term r to the 3 minus 1. The sixth term is the first term r to the 6 minus 1, which gives me 10 equals a sub 1 r squared. 300 is a sub 1 r to the 5th. Isolate a, so 10 divided by r squared is a sub 1. Substitute that here, we get 300 is 10 over r squared times r to the 5th. And then divide out, we get 300 is 10r cubed. So 30 is r cubed. So you get the cube root of 30. Is that what you're worried about?
Yeah, besides, you know,
Oh yeah, you can have weird. I mean, I wasn't sure what you were, how ugly things can get, but it's still if you multiply by the cube root of 30 each time, it's still some rate.
There's a lot of cube roots we can use.
Yeah, you get a lot of that stuff. Let's look at the logarithm style setup when you're dealing with the serious things. So the sum of the finite geometric series had that other formula where it was just a little bit longer, if you will. So the sum of however many, in this case, was what? The first term. And then we have 1 minus r to the n over 1 minus r rate. Now, the reason why they're saying your rate's not 1, because if your rate was 1, you get divided by 0 and all things go wrong. Can't do that. So when we look at, in terms of the sum, find the sum of the first 10 terms. Well, 1, 5, 25, 125, 625, and so on, what's your rate? 5, right?
Times 5.
Times 5. What's your first term?
1.
1. So we start out by writing out the rule. A sub n is our first term, rate to the n minus 1. First term is 1. The rate is 5 to the n minus 1. Excuse me. The sum of 10 of them, well, the sum of 10, we started it with our first term, 1 minus the rate to the n over 1 minus the rate. Well, the first term here was 1. 1 minus 5 to the, we want 10 of them, over 1 minus 5. And again, really the trickiest part here is making sure you put it in the calculator correctly. Use parentheses and your fraction bar. You don't have to worry about the constant out in front because it's just a 1. It's not a big deal. Sometimes if you have one.
We do this one?
Okay. Plus, you can see what's button suppressed. Thank you. No problem. So go right to your fraction bar.
I think we do this
Let's see, alpha y equals enter. 1 minus 5, oops. 1 minus 5 to the 10th over 1 minus 5. There's the sum of them.
Is that, okay, so.
So if I wanted to add up the first 10 values, I would get 2,441,406. It's exciting. Why so worried?
You're not worried.
Sure. Okay. Sweet. All right. Now the weird part. Using the formula itself, I'm hoping you guys saw, was really, really easy. The weird part comes in when you have to find the value of n, however many you have to add up together. And that's where you have to solve for n. And when you solve for an exponent, obviously, that's where logarithms come back. Okay? So let me put this on a separate. Find the number of terms you have to add together to get 3906. We know that the first term was 1 and our rate was 5. It's really all the information you need from the first part of the problem. Write out the formula. The sum of however many is the first term, 1 minus the rate to the n over 1 minus the rate. Well, what's your first term? 1. What's the sum have to equal? And we substitute in 1 minus 5 to the n over 1 minus 5. Okay. So in this case again, does the 1 have any bearing to the problem?
No.
No. So I need to get rid of the fraction. The denominator is 1 minus 5. What do you get? -4. Good. So what I want to do is I'm going to multiply both sides by -4. Okay? So 3906 times -4 is going to be a -42615.
Correct.
Okay. That equals what's left in my numerator, 1 minus 5 to the n. Now remember, when you're dealing with logarithms, your base has to be positive. So I'm going to take that minus 5n, add it over to the other side. At the same time, add that 15,624 to the right. A little exchange-o, change-o. I get 5 to the n is 15,625. Convenient that it ends in a 5. How do you get the exponent to drop, remember? Yes, ma'am?
Log base
Why would it?
What's that?
Wait, how come?
It's one.
Genius.
I added 5 to the end, and I added this 15, 6, 24 to the other side. Because I want to have those positives, that's all.
Oh.
What was it, Kobe?
Log base 5.
Good. I take log base 5 of both sides. Log base 5 of 5 to the end allows the end to drop. So log base 5 of 15, 6, 25 is the answer. However many terms you have.
How do you do log again?
Log, what is it, alpha window 5, I think. Remember my new band, Alpha Window 5s? And 15, oops.
The answer is 6.
The answer is 6. You have to add 6 of them together. That's how it works.
Oh, that's right.
Okay.
Couldn't you
Does
just
that
add,
clear up
like-
some of the confuzzleness on the log stuff?
Couldn't you just like keep adding up or times them by 5?
You can, but what happens if I want to figure out the sum of, like, you know, a gabillion?
Take a while.
It takes a while. If you get the one.
Yeah, or if you don't have a log
That
book,
didn't.
you use a lot of guess and check.
Actually, no,
Okay.
because I put.
I mean, it's not bad, because you can do the table.
Extra.
Yeah, you can, there's a couple of tricks in that one. We okay on that one then? Does that clear that out? All right, let's look at the infinite geometric series real quick about how that one works. When you're worried about the infinite geometric series, this is the last little bit of 11.4. It's the difference between the finite series and the infinite series is very similar. Bless you.
Thank you.
So when you're talking about the infinite geometric series,
Wow. Oh, wow.
oh yeah, I had it on the video, didn't I? Yeah. I thought it was clever.
You had this on the video?
Yeah, you probably weren't paying
We didn't
attention.
actually.
I was paying attention.
You're watching the
Just like-
Masters.
Well, actually, I didn't watch Masters till yesterday.
And then speed.
Sorry, what's that?
Speed.
I said, oh, we didn't actually watch the
Speed
video, but
just-
it just started accidentally.
Oh, it did? Sweet. Worked. Yeah, I felt bad for him. That was like a total tin cup
You got
episode
finished.
too. Did you guys ever see the movie Tin Cup?
Yeah.
Just plops one in the water.
You quadruple bogeyed that
A
one.
par 3.
It's like playing golf with Seth.
He had a 5-stroke, and he's going down on it.
It's so true. So the infinite series, the difference in the formulas for the infinite series is this. There's no n,
16.
because n is infinite, all right? So what's happening is, as it's getting larger, excuse me, as it's approaching larger value, it's just gonna be the first term over 1 minus your rate. Now, there's a whole long-winded proof on how this works, and we're a little short today on time. I will show you the proof of why this conforms from this. It's actually not that difficult to go over, but I just want to show you how it works itself out. Now, the big deal here is that when you have it with your rate, the absolute value of your rate has to be less than 1. Okay? Your rate, just like the example we had a second ago, remember how we had a rate of 5? That would not have an infinite sum. Whereas if your rate was between 0 and 1, you're gonna be okay. If the rate is greater than 1, not gonna work. It has no sum. That's why I put a note in here about pay close attention to R. So if you see these things in terms of lists, as far as how to distinguish between the two, since there's no value of n here because it's infinite, that way you know that it's infinite. Notice, there are only 3 variables. You need to know 2 of them.
Yep.
Okay? I'll show you how it works. So when you're working with one of these things, if you had something written out in summation notation,
Forgot this E.
okay, this is your summation notation. This just means that this is your first term and this is your rate. Will this have a sum? Yeah. Why will it have a sum? Yeah, because your rate has an absolute value that's less than 1. So this one will have a sum. So all we have to do is just take our formula, the sum of this series is going to equal the first term divided by 1 minus my rate. Well, my first term is 3. My rate is 0.7, so it's 1 minus 0.7. I put that in my calculator with a fraction bar and hit enter. And that gives me my answer. Alpha window 5, oops, wrong one. Alpha y equals 1, oops, 3. Yeah, it is. Okay. And again, the only reason why this is going to work is because your rate has an absolute value less than 1. Okay. Yes, sir.
Instead of the 3 with first term and
Yes, sir.
7 with your rate.
Yep. Rates in parentheses. It's always going to be in parentheses.
Again, the I is just like a variable, right?
Mm-hmm.
Okay.
Yes, thank you for reminding me. For some godforsaken reason, they use I's all the time with summation notation. Why? I have no idea. It's kind of dumb, because when I see an I,
Scares people.
well, it shouldn't scare people. Pink eye scares people.
Yeah.
That scares me.
Yeah. I ain't scared of no ghost. I hear you. Yes, there it is. Probably you. Did that new movie come out yet with
I
that?
hope not.
It looked awful.
I hope
I mean,
never-
it looks really, really,
I hope
really
it
bad.
never comes out.
So it hasn't come out yet, or no?
No, the trailer came out.
The trailer came out and it looked so bad that I don't think I would even red box it.
They're ruining
I
Ghostbusters.
think they're making another Star Wars.
I saw that one. That one looks pretty cool.
They're making a more trilogy.
It's not another trilogy. What's happening? What they're doing? They're doing little crosswords, like crossover things. This is the story of how the rebels got the plans for the Death Star.
That's a good.
That's cool. That's a good thing.
It
And
comes out in December.
yeah, then the following December will be
The eighth
episode
one.
8. Then the following December is going to be the Han Solo movie.
Huh.
Yeah.
Wait, with Harrison Ford?
No.
I didn't think so.
No.
It's just the story of him.
Speaking
before.
of Harrison Ford, I told you guys I finally showed my kids Raiders of the Lost Ark.
No.
Well, we showed our kids Raiders of the Lost Ark not too long ago, and my son is a huge Star Wars fan. You know, 7 years old, just loves it. Then also he's looking. Wait, Han Solo is Indiana Jones? Wait, how is he the two of the coolest people ever? Like exactly. Did you know that? What you guys all know, Harrison Ford is an actual accomplished pilot.
Yeah.
He pilots helicopters and airplanes in old World War II. He crash landed on a golf course, that kind of stuff. He owns 1 million acres of land in Montana or something like that. And there were Boy Scout troops that were out there and they got stranded. He went in on his helicopter and rescued them. So imagine being a 13, 14-year-old kid on a Boy Scout trip, and Han Solo, Indiana Jones, is the guy piloting the helicopter that saves you. Is that not like the coolest thing ever?
Yes.
God, I wish I was there.
That'd be way better.
So cool. So, anyway, this one here, it's finding the sum of the infinite series. Is this an infinite series?
Yes.
Why?
Jason
Exactly.
is way cooler than me.
You hear
Oh no!
This guy?
Here's the door!
Wait, what?
Jason Bourne cooler than Indiana Jones.
He is way cooler.
What's your
Jason
rate?
Bourne would wreck him.
Jason Bourne
Negative
would have
1/4.
a Sweet gun.
First term is 1.
Or Chewbacca.
Yeah.
Chewbacca would eat Jason.
Be careful when you have these things. When you're dealing with the rate value, you only worry about the absolute value to tell whether or not it's going to have a sum. You still use the negative when you're substituting in. So you have to make sure you be careful with that. Okay? Like I said, 11.4, there are other things, but just with the lack of time and making sure that we're able to be done with this unit by Wednesday, I'm not going to bother with it. Are we okay with 11.4?
Yeah.
All right. Tonight, I want you guys to finish out any of the leftover questions that you have from 11.3 as far as those logarithm problems. hopefully just the quick little blurb that I showed you, kind of redoing them, helped. And then I'm going to give you a few of these 11.4 ones. And then tomorrow in class, I'm going to go over some review junk with you guys. Let's see here.
Well, it's staying sunny. It's like 50 degrees out.
How many people actually try
Dry stuff probably made.
A lot.
Grassy has the front bed.
One would definitely.
Yeah. Well, it's starting to flood.
You can't pay me for other
You think I'll play or no? I don't know. I want to.
Try those out, please. I did throw a couple on here where it asks you to solve for the common rate. But I didn't show you how to do that, so hopefully you'll be able to figure that out.
And it's like we're getting its hands, probably not going to
Okay.
work either.
Well, if they get they pretty much have to reschedule conference. It's not conference, they don't have to, but.
In the cabinet there, Coach, you see the whole pile of them in the brown box? Yes, perfect. No, he would not.
Oh,
Jason Bourne.
Jason Bourne doesn't even know his
The Han
real
Solo one
name.
comes first.
Jason.
What's
The
that?
Han Solo one comes first.
I thought the Han Solo one was because there's another one that I think
There's a Boba Fett one after the 19th.
Okay, yeah. No, the Bubba Fett is the Han Solo Bubba Fett story.
Yeah.
There's one, but there's another one. What's the third one then? There's another one.
Well, I know the other one they're doing is one that comes out this year. That's like completely
The
separate.
Death Star.
No, there's the
I
Rogue.
think the plans for the Death Star, and then it's
That's gonna be
a
a
story
good
on
one.
Rogue
Yeah,
Solo,
that one looks good.
the Boba Fett one, and then the main story. Like they go every year.
Yeah, that's what I love. I think
Bless you.
They need to stop.